All right, welcome. Thanks for joining section 9.3. We're talking about hyperbolas here. So just a little bit of a warning. Hyperbolas can get a little bit confusing because everything is so similar to an ellipse, yet different, but super similar. So you really have to know ellipses before moving into hyperbolas. Otherwise, you might end up mixing things up a little bit too much. So first, oh, well, I went all the way to the last slide. So let's just go back real quick. Sorry about that. What we're going to be continuing working on is conics. We're talking about hyperbolas. It's again very similar to ellipses, not as similar to parabolas. It's almost identical to ellipses though. So the first thing we want to do is talk about the definition of a hyperbola. Hyperbola is the set of all points x, y in a plane. So the set of all points x, comma, y in a plane, the difference of whose distances from the difference of whose distances from two distinct points, which are going to be our focal points, is a positive constant. So most often people say like, oh, it looks like, two parabolas, and it isn't actually parabolic because there are asymptotes to this. So it's not exactly a parabola, but what forms the actual hyperbola is the set of all points that are equidistant from two different focal points. So you can see here, if we have this point x, comma, y, the difference of those. D1 being our distance to one focus, D2 being distance to the other focus. The difference of those is a positive and constant. So no matter what point I picked along this hyperbola, even if I picked one down here, the difference between the distances of these focal points will be a positive constant value, which obviously changes depending on which hyperbola you're looking at. So the graph of a hyperbola has two what are called branches. So they're not two parabolas, they're two what we call branches. And the vertex of each branch and the focal points fall on what is called the transverse axis. And you can sort of think of the transverse axis as being sort of like a major axis from an ellipse, where that's what's going to tell you a little bit about what type of equation we're going to use. The center is equidistant from the vertices and from the focal points. So my center here, and notice in this case, the center is not inside, really. It's not contained within the hyperbola. It's sort of between. So my center is the midpoint of my vertices. It's also the midpoint to my focal points. You can also see A and C represent the same things as they did with an ellipse. A is the distance from center to vertex. C is the distance from center to focal point. All right, the standard form for an equation of a hyperbola. So we have two. We have one that goes x minus h squared over a squared. So far, same thing as a ellipse. And then I'm just going to leave some space here, y minus k squared over b squared and equal to 1. The only thing that makes this different from an ellipse is now it's going to be minus. So essentially your x and your y are working against each other. This is the case when the transverse is horizontal. So think about like your horizontal major axis. So you're thinking about a hyperbola that looks like that. Your other case, it's not a squared and b squared, exactly that switch. What it's going to be that switches for a hyperbola is the numerators. So we're going to have y minus k squared over a squared minus x minus h squared over b squared equaling 1. So again, with an ellipse, what switches around is a squared and b squared, depending on the transverse, I just did air quotes again, the transverse axis, which again, is called the major axis for an ellipse. But for a hyperbola, what's switching is the numerators, and that's still dependent upon that transverse or that major axis. So here, the transverse is vertical, which means my hyperbola's branches are opening up and down. So to give a little bit more of an explanation, here we have a transverse axis that's vertical, here a transverse axis that's horizontal, and what those equations would look like. Again, keep in mind that the a squared is in the beginning regardless. What's switching around is your numerators, your binomials. H comma k still represents the center. A squared, or a more specifically, still represents your distance along x. B represents your distance along y. And c represents your focal length. So the center of the hyperbola is h comma k, nothing different. The vertices are a unit from the center, nothing different. The foci, or focal points, are c units from the center. And again, a little bit different here. C squared is equal to a squared plus b squared. So that plus is what's different for a hyperbola. If you think about an ellipse's equation has plus, but its c is minus. So a hyperbola, our equation has minus, so our c squared has plus. It just switches. And then the really cool thing is that the end behavior of hyperbolas is asymptotic. Or asymptotic. Recall the meaning of asymptotic. What that means is that you have two lines, well, in this case, it's going to be two lines, in which the hyperbola is constantly going to get closer and closer and closer to, but it's going to be bounded by them. It's never going to cross over them. So a hyperbola will have two linear asymptotes that intersect at the center of the hyperbola. So the center, not the vertex, the center of the hyperbola is where my two linear asymptotes are going to intersect. Asymptotes will always fall in the same sort of pattern. So we have y equals k plus or minus b over a times x minus h, and y equals k plus or minus a over b times x minus h. Now this is for a horizontal transverse. Let's put oh my goodness, just don't even spell. You know, this is why I teach math. Transverse. And this is for a vertical transverse. Notice again, these equations almost identical. You just have to remember the a over b versus b over a. And then know which one obviously goes with which. This goes with horizontal, b over a. B and a just representing those distances along x and y. Now, what we're going to have you guys do is write out the asymptotes, but graphically, we're going to show you a trick to how to graph the asymptotes, even if you didn't know what this equation was, so that you can still graph the hyperbola correctly without having this equation. Okay, all we have left is a whole bunch of examples except for this last slide. This last slide, general equations of conic sections. So classifying a conic from its general equation. If we had something in the form of ax squared plus cy squared plus dx plus ef plus f equal to 0. So if I just have a, c, d, e, and f represent any numbers, and this is set equal to 0, then you can sort of figure out what type of conic this is, and this is something we will ask you to do, is just determine the type of conic based off of a general equation. So if a is equal to c, if the lead term of x squared and the lead term of y squared are equal, this is a circle, as long as a is not equal to 0. You know, if those terms don't exist, it's not a circle. For it to be a parabola, the product of those things needs to be equal to 0. So either a is 0 or c is 0, but not both. So just think about your parabola equation. You always had an x squared or a y squared, but you never had both. The fact that one of them was missing meant that the coefficient of it was 0, which is what makes it a parabola. In order for it to be an ellipse, the coefficient of x squared and the coefficient of y squared must have the same signs, which means that the product must be positive. And again, it has to be equal to 0 first, but if I know that I have like a 10x squared and a 7y squared, and then only these other terms, I could say right away this is an ellipse. If the opposite is true, if they have unlike signs, one positive, one negative, doesn't matter which one's positive or negative, then I know right away it's a hyperbola. And this just sort of accelerates some of the, like, if I'm looking at a equation, recognizing what this looks like to give you a rough idea of what type of function we're dealing with or what type of equation we're dealing with. All right, all the examples I'm going to deal with the graphing and writing equations of these. So just make sure that you have down that general information, that terminology. Make sure you know transverse, the equations, c squared. Otherwise, have some fun.